Hello friends, welcome to the last session of this video regarding the laws of motion. In the previous session we studied about the first law, second law, and I had a little demonstration or explanation about Newton's third law. This third law explanation is fully based on, as we know that this law is valid everywhere. Without third law implementation we cannot move even a single step. So the exact information or exact conceptual relation about the Newton's third law, that is, as you know, that equal and opposite pair of forces, these are equal and opposite pair of forces between two different bodies, not in one body system. So to understand the better conceptuality of the third law, we need to learn about the friction. So before starting the friction, I will be putting the friction chapter in a separate video itself. But right now, in the previous video, I did not share about Newton's third law, because theoretical explanation is another thing. But if you go for the practical implementation of the fact, then you need to go for the mathematical calculation, and that is better to be understood in friction. So I will be leaving the Newton's third law session for this friction chapter, which I will be sharing in the next video. Here I am going to discuss one of the very important session of laws of motion. That too is the last session, and that is named as pseudo force. Pseudo force. This is one of the very important session. Why? Because majority of the questions which you people will be dealing in laws of motion, you will find the basic trouble in some of the issues. And what is my experience during the teaching time, that while you are dealing with the tedious question of laws of motion, 80% of the questions are dealt in better way, or I should say in easier method, when applying the pseudo force. So what is my intention, that other than those things we studied in the previous videos, this session where I am going to discuss about the pseudo force, you should be more habituated to deal with this concept, because every time if you are very clear with this concept, the questions approach will be very easy for you to deal. So let's begin with the pseudo force application. What is pseudo force, and how these things help us to deal with the questions and the solution of the different type of questions. So before starting pseudo force, we need to know about frame. There is one term, frame. Frame we know is an English term, and if you find the meaning of this word, that is frame structure. Structure means whether you are like a photo frame, the photo is there in a frame. So this frame has the same concept here, but in some different manner. Frame means whatever in physics we study, all things has to be studied when there is an observer. Suppose a vehicle is running, a train is running. So train is running means there is aspect. How I am saying the train is running, that I am in the ground and just looking into the onto the train, and we see that train is moving. At the same time, the person inside the train feels that train is not moving unless he is seeing outside. So if he is seeing the train, if train is locked, completely packed, there is no any light coming from outside, and person is sitting inside the train, what he will experience? He will experience the train is at rest. But the fact is, train is not in rest, the train is moving. So all those parameters, whether the object is moving or not moving, depends on the place from where the observer is observing. I mean to say that suppose I am taking one more example. Suppose a car is moving and a person, there are two observers. Suppose this is a car, I am taking this as a car. There is one observer on the ground, and there is another observer which is in the car. So suppose this is moving ahead. So if you are seeing from the ground, this car is moving in this direction. But at the same time, if this observer is observing this car, with respect to this observer, the car is at rest. So this is what all about the frame. This is called the ground frame, and this is called the corresponding frame of the corresponding car or any other components. So based on the observer, from where observer is seeing the object, the frame has been decided in two parts. The frame is of two parts. The one which is called inertial frame, and another one as non-inertial frame. You just go through the complete video session. It will take hardly 20 to 30 minutes to discuss the frame, because this is important. Why? Because the person who is sitting in the place, suppose I am sitting on the moon, so from my side the earth will be rotating. But if I am sitting on the earth, for me earth is at rest. So all those things on the physics depends on from where the observer is watching the object or corresponding issues. So let me discuss about the frame. So as I have told you that frame is of two types. One is inertial and another one is non-inertial. This inertial frame is also known as non-accelerated frame. Non-accelerated. I will discuss all these things in detail. Non-accelerated frame. And this non-inertial frame is also known as accelerated frame. Accelerated frame. Now, what is more important to deal here, that in inertial frame, how will we identify that the observer is in inertial frame or non-inertial frame? So it's very easy that if a body is at rest, or if a body is at rest, it means velocity is 0, or if velocity is constant, The condition for inertial frame is very easy. There are two things to be understood and be very clear to identify which of the frame we are working upon. So I am here explaining about the inertial frame, where what you need to visualize or identify that the observer is moving with 0 velocity, that is it is at rest, or it is moving with constant velocity. If such condition acts, then the frame is known as inertial frame. And if velocity is not constant, that is if acceleration is not equal to 0, it means this frame will be accelerating. So such type of condition is called non-inertial frame, in which the observer is also accelerating. For example, two trains are running with respect to one and each other, and the observer from one train will be watching another train, so both the trains are accelerating. So that time the frame will be non-inertial. I will be explaining one more example here, that suppose this is a block, suppose a man is the observer is on the ground. So what type of frame it is? Here v velocity is 0, it means the frame is inertial frame. Very clear. Again I am taking one more example. A person is there on the car, then from this observer side, and this car is moving with velocity 2 meter per second. What type of frame it is? It is again an inertial frame. Why? Because I have mentioned two conditions for inertial frame. The one, that the observer should have the velocity 0, or observer should move with constant velocity. It means if car is moving with 2 meter per second, this observer would be moving with 2 meter per second. So again this is an inertial frame. But this condition is not valid here. Suppose a car is moving here, and another observer is accelerating again with some 2 meter per second square. So this observer is moving with 2 meter per second square, and this car is moving with suppose 4 meter per second square. So with respect to this is again an non-inertial frame. Why? Because the observer have some acceleration, and the special condition and the specified condition for non-inertial frame is that observer should have some acceleration in non-inertial frame. Now you will see why these things has to be discussed. The very important session, why these two things has to be discussed. The very importantly, I should say that the Newton's second law or Newton's laws are valid in inertial frame, not valid in non-inertial frame. So if I say wherever we have applied Newton's second law in the previous sessions, all those frames were inertial frame, all those observers were either from the ground or moving with some constant velocity. So the very important thing is that Newton's law of motion, I should say NLM, works only in inertial frame. It does not work in non-inertial frame. But actually fact is that Newton's second law or Newton's law is a universal law. So whether inertial frame or non-inertial frame, it should act. Actually in non-inertial frame also the body is moving, but it depends on observer. So to justify the second law of motion in non-inertial frame also, there is a force which is actually not feasible, which is actually not available, but still to justify the Newton's second law, there is one type of extra force is added to justify in non-inertial frame, and that force is called pseudo force. I hope you understand the fact which is the responsible factor for non-inertial frame to get justification of Newton's second law. Very clear. Again I will summarizing the fact that frame are of two types. One is inertial, another one is non-inertial. Inertial frame is also known as non-accelerated frame. Why? Because velocity is zero, velocity is constant. It means acceleration is zero, and if acceleration is zero, then it is a non-accelerated frame. I have given the example, and what I mentioned, that Newton's law works only in inertial frame. Comparing to the inertial frame, non-inertial frames are accelerated frames where observer have some velocity, have some variable velocity, that is the acceleration is not zero. The frame from which the observer is observing is itself accelerating. So in non-inertial frame, Newton's law is not valid. But since we know that laws of motion are universal law, so the non-validation in non-inertial frame is again a contradiction. So to justify or to implement the Newton's law in non-inertial frame, there has been introduced one of the forces that is known as pseudo force. In further session, I will be discussing the pseudo force concept. Let me take one example. Suppose, very simple example I am taking. Suppose there is one body of 2 kg mass having an external force of 10 Newton. If I am saying that what is the acceleration of the block? So what is the acceleration of the block means I am asking you. So how will you see? You can see in two ways. One, right from the ground, and you can from ground you can see that there is an external force of 10 Newton and body is having the mass 2 kg. So from ground there is no any issue. Again, this ground we are sitting here our velocity is 0. Our velocity is 0 means we are in the inertial frame, and if we are in the inertial frame, Newton's second law is directly implemented, so that we can easily write the equation as mass into 10 force F net equal to mass into acceleration, that is 10 equal to 2 into A. From here we can get the value as 5 meter per second square very easily. There is no any contradiction. Why? Because the observer, all the things depends on observer from where the object is being observed. So in this example, the question is the issue is that we are on the ground and velocity is 0. But the same fact does not work when the observer is sitting in the car itself. Now I will take one example so that you will understand in a better way. That suppose this body is moving, suppose this observer is moving, or observer is inside. So observer is inside means what will be happening with respect to the observer. Suppose I am taking the figure out. This is 10 Newton force acting and this is 2 kg mass. Now observer is sitting itself in the car. So what will be happening here? With respect to this observer, the whole system is at rest, but actually it's accelerating. So what is pseudo force implementation? Tells that you just implement the observer's acceleration. Observer's acceleration means this is 5 meter per second, because this observer is also moving in the car. Observer is moving with 5 meter per second. Apply this 5 meter per second on the 2 kg mass in the direction opposite to the motion of the particle. Let me again repeat the term what I want to say to apply in pseudo force concept, that all the observers who are accelerating, suppose observer is here and actually this observer is moving with this 2 kg block. So the acceleration of the 2 kg block and the observer is 5 meter per second square. But we cannot directly apply this concept to identify Newton's second law. So one new pseudo force has been implemented. Pseudo force explains that mass of the body should get multiplied with the mass of the body in the direction opposite to the motion of the body. So if the body is 2 kg, so we will apply the amount of force on this 2 kg block in the direction opposite to the direction of the motion of the car. So this acceleration is A. A means observer acceleration, that is 5 multiplied by its mass. This is what the pseudo force is being implemented. I will give you one more example that is very famous, that is lift concept, so that you can understand this pseudo force concept in very proper manner. Lift concept, this is also very important, and this is one of the very good example to analyze this pseudo force concept. Suppose we are moving in a lift. This is a lift, and there is one boy sitting in this, and I want to identify this body is moving with some acceleration A. Now one generalized question is coming in my mind. Whenever you are standing on a weighing machine, what it measures? Whether it measures your weight. Suppose you are on a weighing machine standing on a weighing machine, you generally see 45 kg, 60 kg weight. What actually weighing machine measures? Is it measuring your weight? No, it never measures your weight. What it measures the normal force acting on your body. For example, suppose this is a weighing machine. This is a weighing machine. A man is sitting here. So the amount of force acting on the weighing machine by you is mg, no doubt. But this weighing machine is not measuring your mg amount. This is actually measuring the normal force applied by this weighing machine on your body. This is very important, and this thing will be very clear here also. So remember that weighing machine never, multiple type of questions has been asked on this session, that every time somebody has been put on the weighing machine, they are exactly pushing what is the reading. So reading is not about the weight, total mass on the weighing machine. This is all about the amount of normal force acted upon by the weighing machine on the object. Now you see the example. This is very example. This will be very easily understood in this concept here. Suppose a lift is moving with some acceleration a, and now let me check one weighing machine here. One person is on the weighing machine sitting in the lift. Now what I want to say, if I am saying to identify the relation in normal, or to find the acceleration of the body, or find the normal value, so what can I do? I will draw the free body diagram. So this free body, and this is from inertial frame, that observer is from ground, I am on the ground, so I am watching that this lift is moving in upward direction. So what will happen, from my side I can see that the body is moving in upward direction. There is no any doubt. Suppose a person is sitting in the lift and we are watching from the ground, the lift is moving, and hence simultaneously the person in the lift also moves in upward direction. So for me the FBD is like this. Normal contact force is in upward direction. Of course this weighing machine will be putting some force on the body, and there will be one mg amount of force in downward direction if I am taking the mass of the body as m. And what we are observing, that the body is moving with acceleration a. So which frame I am dealing? This is an inertial frame. Why inertial frame? Because the observer is sitting on the ground. Now the question is very simple, that the body is moving in upward direction, it means normal force is greater than mg. This implies, applying the Newton's second law, this is normal force minus mg equal to mass into acceleration. Now you identify the concept which I have mentioned right now, that the amount of normal force applied with the weighing machine on the body is ma plus mg, not mg, because the mass of the body cannot change, so the amount of mg force will not change, but normal force will change according to the movement of the body. So the overall weighing of the machine will be m into a plus g. This is what I wanted to share. So if a person is sitting in a weighing machine moving with some accelerated value, then his weight will not actually be mg, his weight will have some value amount with g, and some value with the accelerated body, some value that with which the body is accelerating. Again I am taking one more example, but this was the inertial frame implementation. Here again we have the observation that this station was observed from the ground, but if a person again sitting here itself, I will taking here, let me again explain. Suppose this is a lift and the person is sitting here to whom we have to observe, and in the first frame, that is in inertial frame, we observed from ground, and now I want to solve this question in non-inertial frame, that is observer is also sitting in the frame. Now what will happen? With respect to this observer, this body is in rest, the body is not moving, and if body is not moving, it means what I said, to draw the FBD of this body, first you put the structure. Two things are very clear, that this have the one normal force in upward direction and the amount of mg in downward direction. Now what we will going to implement here, the term pseudo force, because Newton's law is not valid in non-inertial frame. So what will we do here, the amount of acceleration that is existing with respect to the observer, as the lift is moving with a acceleration, so this observer is moving also with a acceleration. So to identify, to get the value of this a acceleration with respect to observer on this object, what is needed is to take the acceleration of the observer multiplied by the mass of the object in the direction opposite to the motion of the object. So what I want to say, that acceleration in upward direction, so what we need to apply, acceleration in downward direction multiplied by the mass of the object. This is what the pseudo force. This is pseudo force. Now you see, we can easily balance the question, that normal force in upward direction, ma is in downward direction, mg is in downward direction. So while applying the equation n equal to ma plus mg, that is m you can take common, a plus g, same thing. Now you just see that the implementation from inertial and non-inertial frame with small implementation of pseudo force, the concept remains the same, the solution remains the same. This is one of the very important example to for better understanding of pseudo force. I will take one more example. I hope you understand. If you go through multiple times through this video, you will understand in a better way. I will take one more example. There is no need to put worry. Examples can have multiple options. So again, I am taking the lift itself. Suppose this is a lift, and again the same condition. The object is here, and now the acceleration is coming down. Now you see the condition. Again, any physics question can be solved from inertial as well as non-inertial frame. But for my advice would be, in such type of questions, you should practice as much as possible to get the implementation of non-inertial frame, because non-inertial frame or implementation of pseudo force makes the complicated questions also to be solved within 3 to 4 steps. So in better understanding, for the higher implementation of pseudo force, I will be making one more video in advanced session to get the further implementation, that is the magic implementation of that pseudo force, to get the result of various questions. So again I am repeating that you should focus on more on non-inertial frame, because multiple type of questions can be solved easily in the non-inertial frame or accelerated frame. Now suppose this is the example. This is the last example I am sharing with you, and the example is connected with that. The lift is there and lift is coming down. I am just dealing this question in two ways. This is one of the inertial frame, and inertial frame Newton's law is valid, but in non-inertial frame Newton's law is not valid. So in both the methods we can solve the question and answer will be same. Here there is no need to inertial frame, there is no need to put any pseudo force. If inertial frame means observer is on the ground. Suppose this lift is coming down and I am sitting on the chair. So for me, this is an object, and this object is coming down with an acceleration a. But one more explanation is there, observation that this surface is applying a normal force in upward direction, and the amount of force gravity is applying is the force acceleration of the g and multiplied by mass. This is the overall observation. That is very simple, and now we can easily apply Newton's second law, that this mg is greater than normal force. So the net force is coming down. It means mg minus n equal to mass into acceleration. From here we can find the normal value as mg minus ma. This implies m into g minus a. This time, if the observer is sitting on a weighing machine, the weighing machine will measure the amount of force, amount of weight of the body as n into g minus a. It will not measure mg. So you should be clear with this. This question again I am going to implement in non-inertial frame. Non-inertial frame means the observer is, this is lift, and the observer is sitting in lift. It means the observer is also accelerating. That is the important thing in non-inertial frame. If observer is accelerating, in this condition, with respect to this observer, object is at rest. So very simple, I am again drawing the FBD. This is the object. I am talking about the mass. This is the object, and we can visualize that one normal force is acting in upward direction and mg in downward direction. Now what I told, that before applying the pseudo force you need to reverse the acceleration direction. So I am putting in the reverse direction like this, multiplied by the mass of the observer. This is what about the pseudo force. Now you implement, you write down the equation n plus ma equal to mg. This implies m equal to mg minus ma, taking out the m common, g minus a. I hope you understand the comparison of the implementation of inertial and non-inertial frame. This is all about the pseudo force. I will be sharing some assignments, some worksheet with you people, because these things have unlimited scope to solve the problem. So I can take a small amount of examples, and from your side it's important to practice more and more. In the last session of this video I will be sharing the assignments on the various topics which I have discussed, and rest, the friction force and the Newton's laws, third laws, will have the better explanation in the next video. Thank you.